Okay, so I'm assuming that you already know how to set up to solve things and how to find. When I say parallel, force parallel to the plane, perpendicular to the plane, we're talking about components of gravity, one parallel to the plane, right? And then one perpendicular to the plane, right? To find the parallel component, force parallel is going to be just mg sine theta, right? And the way you remember this is, of course, if this angle here is just 35 degrees, if that ever became zero, there'd be zero force parallel to the plane. This is why we make our floors level, because we don't want marbles to roll along the floor, right? So sine of zero is zero, so that's the trig function, right? So I'm just going to plug this in, 2.15 times 9.81. We really can't, we can't afford to think about this too much, right? Okay, times 35. So why it is this way is explained elsewhere. Okay, so that is, if I do that, hold on, hold on here, I get 12.098 newtons of force. Okay, so that's our 12.1 newtons, and that is there it is, right? Okay, now we want to find the force perpendicular to the plane, right? Okay, force perpendicular is mg cos theta. Now think about this. It's easy to remember that it's cos, because if that angle is 0, it's a level surface. Well, cos of 0 is 1, and so the perpendicular force is all the weight, right? So that's going to be 2.15 times 9.81 times cos of 35. So now let's do that. Let's go second entry, and all I have to do is change sine to cos. And let's store that in, I'm storing these in my calculator, I'm so lazy, 17.277. Right, so 17.3 newtons, there we go. Now we'll use these values here. In the rest of the video, we'll use sort of more accurate values. These are rounded for the sake of manners, but you know, who cares about manners, really? I mean,